Hello.
Hi, Kiran. Good morning.
Hi, Dayan. Very good morning. Very good morning. Apologies, I couldn't able to make it in time yesterday, Dayan. We again all shifted back to home now due to the increasing cases of COVID. So we all were in that arrangement yesterday throughout the day.
Okay,
And later on, I realized that I missed the call. So that's why I pinged you late.
no problem.
Yeah. Yeah. So everyone is here now and we can get started.
Okay, sure. So, in the last session, we were doing the chain code deployment, right? So, we'll continue the
Mhm.
same. So, we have
Okay.
completed the total 6 steps, right? So, we'll continue from step number 7. Okay,
Mhm.
let me share my
Mhm.
screen. Actually, I had deleted my network and I up my network again. So what I
Okay.
will do is I will rerun this 6 steps and then we'll continue from 7. Okay. In your machine also, if the network is down, then you can just rerun the complete thing.
Actually, my machine I haven't connected yet because I just brought that yesterday evening only. So I will connect and try that out from my end. And if there are any issues, I will let you
Okay,
know. So
sure.
have you posted that lab 3 link on the board, Trello board,
1 minute. I just do it right
or
away.
you can give it to me again, and I will
Yeah.
post that on Trello.
Okay. So this is the link.
I will add that on Trello.
Okay. Yeah. So let me just package the chain code. Okay. And after that, let's try to install the chain code on organization 1. So it may take some time. So
Mhm.
let's wait for it. Meanwhile, others also, if you are following,
Yeah.
so
Yes.
just try to rerun if your network is stopped or something. Okay, so it's done. Same thing I will do from second organization. Okay, so it's done.
Mhm.
Now let's try to query. So when we query the chain code, we'll find. Okay, so my chain code has been installed now. Okay, so now the next thing is I have to create one new file, new script file inside the scripts folder. That is set package ID. Okay,
Mhm.
so this will be the name. So why we are creating this set package ID.sh, because we would need the complete package name. Okay, so with the hash, This is the hash of your chain code, right? So we'll need this complete package ID. Okay, this one later on also. Okay, so in various command we have to pass the package ID also. So better to just export here itself. Okay, so let's open the 1 minute. I need to open the Fabric samples. So in my Fabric samples, just open your scripts folder inside the test network, and in the script folder you have to create one new script file. That file name would be set package ID. Okay, and inside set package ID, this 3 line of code we have to write it down. So let me tell you what exactly is happening here. So basically we are just setting up the package ID here. Okay, so package ID is a combination of our chain code name, okay, and the version. Okay, and then that same package ID we are going to export, and then lastly we just echo that package ID here. Okay, so now let's try to run this, and when we run this, we'll get the package ID in the one file. That file is out file. Okay, so one file will be created in the VS Code or in the folder, and there you will find the out file. Okay, so let's try to run this. Okay, so this is my package ID. You can see here fabcar_1 762E0 FE, and then same thing. If you open the VS Code, you will find one out file here. So here you will find install chain codes on peer, and this is the package ID. Okay, so remember one thing, like this is one time, like like if you create a hash of something, right? So that hash is fixed. So if you try to manipulate something in the chain code, if some, like let's say someone is trying to hack your network, okay, or he is trying to change some let's say functions or some logic in the chain code. Okay, so that is not possible, because when we deploy our chain code, okay, so we manage the hash, and on the basis of hash the version number will be decided. Okay, so this is the hash which we have generated, and this hash will be installed in your network with the specific version number. Okay, and with that specific version number your chain code will be executed. Clear?
Yes. So this
now
is specifically, we can say that as an identifier of that chain code.
correct, yes.
Package
So,
identifier.
yes, so the package which just now I have installed, okay, so that package will be identified by this package ID. Okay, and in the package ID what we have is, first is chain code name, then version, that is 1, and the hash of your package. So here we have the package, right? fabcar.tar.gz. So complete hash we generate, and that hash is this one. Okay, let's say tomorrow someone try to manipulate this fabcar.tar. Okay, he just changed the business logic and then he try to manipulate this. It is not possible, because this hash will be changed, and if hash is getting changed, then it is like you cannot do anything else if hash got changed, right?
Yes.
So this is the concept here, and now next thing is, once we create this hash, once we create this package ID, okay, so the next thing is, since we are in a distributed network, right, or let's say the decentralized network, so here my organizations are like they are not available on a single machine or single host. Okay, of course in the for a learning we are doing on a single machine, but in actual production environment this is not the case. So multiple organizations will be there, and they will be hosting their own containers, right, or own organizations. So in that case we have to get the approval. Okay, since the chain code is the main thing. Like your complete business logic depends on your chain code. And if someone is manipulating the chain code, then there is no use of using blockchain, right?
Right.
So for that reason, the procedure or the mechanism here is, whenever we create a package ID, okay, so we create a package ID. So on that package ID, on that chain code, actually, everyone should agree. Okay, then only that package or that chain code can be deployed completely and it can run on the network. Okay, so every organization should agree that, like they should agree, okay, this is the package ID, okay, we are agree, we are approving the request, we are approving this chain code, and this chain code can be deployed on the network. Okay, so for that, what we have to do is, on step number 8, okay, so the very first thing is, first we will get the approval from first organization, that is org1. Okay, so let's give the access to org1, and then we have the command. So command is peer lifecycle chain code approve for my org. Okay, this is the sub command, approve for my org. And then we'll provide the local host, that is order information, then TLS, CA file, channel ID. So channel ID, you know, like my channel. Then chain code name is fabcar, version is 1. Init required, yes. So init required meaning, once you deploy a chain code, the very first function which we are going to execute, or in every chain code, whenever you deploy your chain code, the very first function you have to execute is init function. Okay, I will show you where exactly the init function will be there. So it, like when we write our chain code and when we deploy our chain code. Okay, so the very first thing what you have to do is, you have to write, when you do the development, you have to write an init function. And at the time of like executing the chain code, you have to run the init function. Very, like, that is a must. Without init function, you cannot use the chain code. Okay, init function is just like, let's say you have installed the Excel in your laptop. Okay, you have just installed it. You are not doing anything. So until unless you double click on the icon and you open the Excel application, you cannot create any sheet, right? Any Excel sheet. Similar way here also, we have just installed the chain code. Okay, so with init function, we are just starting the chain code also. Okay, we are just initializing the chain code. Like after this, you can work, you can execute any kind of transaction on the chain code. Okay.
So is init function like constructor of any class that we can say, which get executed when we create instance of that class automatically?
No, it is an independent function actually.
Actually, these are the functions.
Okay. So init function is an independent function which is written, which we write on the chain code, the chain code which we are going to write. So we write on that chain code. Okay, that is an independent one. And but the requirement is, the very first function which should be executed, that function should be init function. Okay, then after that, package ID. So here is the package ID. Just now we have exported the package ID and the sequence number. Sequence number is version 1. Okay, so let's run this. So here, now you can see one transaction ID is getting generated. Okay, so why a transaction ID is getting generated? Because if you see here, ultimately a change is happening, right? It is not like whenever any kind of activities, any kind of operation happens, that is a write operation, that time Fabric will execute that activity as a transaction. Okay, so, and it is happening on, it is not happening on your business logic, it is happening on the core Fabric. Okay, if you remember, I in the theory session we discussed about system chain codes and application chain codes, right? I hope you remember that. Okay, so here, this is the place where system chain codes are working. Okay, they are executing the transaction, and after executing the transaction, we are getting the transaction ID. This is my transaction ID.
So it's just like deploying smart contracts on Ethereum.
Yes. So there also, I think you must get the transaction ID,
Yes.
right?
Yes.
See, very similar. So here also, whenever you do the deployments, or whenever you like basically whenever you do any kind of activity which will change something in the network, okay, which will write something to the network, okay.
Mhm.
So that time that change will go as a transaction.
Okay.
So
So in case of Ethereum, when we deploy smart contracts, it charges some transaction fees and gas fees, all that. But that is not the case with Hyperledger.
yes,
Or
so
deploying
we
Chaincode.
we don't have any coins and nothing, no cryptocurrency involved here. So
Mhm.
and this is our, like you can say, your independent code, okay. Just like if you write a very small application in .NET or Node.js, and you are sole owner of that, right? So
Yes.
similarly, if you are creating a network here, so you are sole owner of that. You don't no need to give any kind of fees or license cost to anyone. Okay.
Okay.
So now, like we just send the request for approval, but whether the application has approved the chain code or not, or the organization has approved the chain code or not. So let's check it out. How we will check that? So we will use one function. That function is check commit readiness. Okay. So with the check commit readiness, we'll just pass the channel ID, chain code name, version, sequence number, okay, and then output JSON. So basically whatever output will come, that output will write in a JSON file. Okay, so let's check it out whether the organizations has approved or not. Okay, so the output which you will get is something like this. So org1 MSP is saying true, org2 MSP is saying false. So if you remember, I have just sent the request to org1 only. Okay, so org1 has approved the chain code. Okay, but R2 is still, it is coming false. Why? Because we haven't sent.
They haven't yet executed.
Okay, so we still yet to send the request to organization 2. Okay, and this response is coming from first organization. If you remember, here I have given the access to first organization from the terminal. Okay, so this is the response coming from first organization. Now, when you work on the distributed environment or decentralized environment, you have to be in a sync, right? So let's check it out whether from organization 2 the same response is coming or not. Okay. So for that, what we have to do is just set the environment variables. Okay. And then same command, check commit readiness from organization 2 also. So we should receive the same output. Okay, if your organizations are in a sync, if they are running on the same network, so you will get the same output. Clear? Now this is done. I'm clear, like from org1, this is they have approved. Now let's send the request to org2 also. Okay, so to send the request to org2, we have to use the same command. So the command is here, peer lifecycle chain code approved for my org with the channel ID, chain code name, and other details. Okay, and I already set the environment variable to 2. So now my terminal has access to organization 2. So let's send the request now. Okay, so again new transaction happened because a new change is happening, and I got the localhost success valid. Okay, now let's check it out, the check commit readiness. So since I'm having the access to terminal, organization 2 from the terminal, so I will run it. So I will again run peer lifecycle chain code check commit readiness, and this time I should receive true from both the organizations. Okay. Now let's check it out from first organization also. So to check from first organization, what we have to do is we have to give the access. So just run the set the environment variables and then run the check commit readiness. So from organization 1 also, I'm getting the response org1 MSP true and org2 MSP true.
Mhm. So both the orgs have that chain code now.
Yes. So both the
Successfully.
organization has chain code also, and they have approved also. Okay.
Mhm.
They are fine with the chain code. Okay.
Mhm.
Now, once everyone is fine with that, so next thing what we have to do is we have to identify the endorsing peers. Okay. If you remember, the very first requirement or the very first transaction request will go to the endorsing peers, right? So after deploying or after checking the commit readiness, okay, and before commit that chain code to the channel, what we have to do is we have to identify who is my endorsing peer in the network. Okay.
Mhm.
So for that, we have to write a new script file. That script file, which name is set peer connection params. So here, let me give you the file name. So create a new file, name that file to set peer connection param.sh. And here, okay. So what is happening here? Let me explain you. So basically, this 4 line of code will be executed, but in this 4 line, a lot of things are happening. Okay. So line by line, I just show you what is happening.
Mhm.
Okay, just create this file and then I'll start explaining you. Done.
Has anyone done that? Gayatri, Anirudh?
Actually, there was some connection problem with my system, so I've just joined. I missed some part. I will try to run.
Okay. Others?
Sir, system is facing some issue while up network, so I will try after that resolving that.
Okay, fine.
Okay. Okay.
Yeah.
Just try out and let know
Yeah.
when you
So
are.
at
If you are
least do
having
one
any.
thing.
Yeah.
This like create the files. Okay, and at least put down this code on those files.
Mm-hmm.
Okay, fine. So let's come back here.
Hello?
Yes.
Actually, I have a doubt. I was trying to up the network yesterday, but it was showing error. Then I tried to turn off my VPN and then tried, then it was working fine.
Hmm.
Is this a problem with VPN or something?
Maybe, but it's not happen because you're running on local host, right? So
Yeah.
Mm-hmm.
it is not dependent to any network or something. But if your firewall is creating problem with Docker, then it might be a case.
It was not up. My network was not getting up.
So
So
if do you have error?
no, now I
Or
have don't have. Like
okay.
I have turned
So
my
whenever
VPN.
next time whenever you get, just send me that error. Okay.
Yeah.
Yeah, no problem.
Okay. Yeah. So let's try to understand what is happening in this set peer connection params. Okay, so basically my goal here is to set the endorsing peers, okay, or identify the endorsing peers. So what I'm trying to do here is I am first importing the envwar.sh. Okay, envwar.sh is here. Okay, it is also available in the scripts, and inside that I'm calling a function that is parse peer connection parameters. Okay, right, and then passing the arguments. So in the arguments, what we are going to pass is we are going to pass 1 and 2. Okay, 1 and 2 meaning we are going to identify the endorsing pair for both the organizations. Okay, arg1 also, arg2 also. Okay, now let's go to this env war.sh and let's look out for parse peer connection parameters. Okay, so here we have different functions. So one function is this one, parse peer connection parameters, right? So basically, when you run this set connect peer connection params.sh, this function will be executed. Okay, so when we execute this function, what happens is it will just identify. So for first organization, it will identify peer 0 org1 as a endorsing peer, and again when you pass 2, then it will identify peer 0 org2 as a endorsing peer. Okay, so it is setting up like a peer 0 org1 and peer 0 org2 as the endorsing peers. Okay, so this is the function which will be executed. So now let's try to run this and set the environment variables. So this is the output you should get. Okay, so after this, I'm now good to go to commit the chain code definition. Okay, so now let's commit the chain code. So to commit the chain code, the command is peer lifecycle chain code and commit. Okay, then your order information, channel ID, then chain code name, then peer connection params. Just now we have exported, then version number, sequence, and init required. Okay, and let's execute it. Okay, so now one transaction happens, and with that transaction, our chain code has been started. And now let's run docker ps. Okay, so you will see 2 new containers has been created. Can you see dev peer 0 org2.example.com fabcar_1 and the complete hash of your chain code, right? And similarly for second organization also. Okay, so here one thing to remember is until unless you commit the chain code, your chain code container will not be started. Okay, you will install the chain code, that's fine, but until unless you commit the chain code, after commit the chain code only your chain code containers will be started, and then you can execute the transaction then. Okay,
Okay.
now next thing is, like this is fine, like I can see, okay, my chain code container is running fine, that's fine. But if you want to query like whether the commit has successfully happened or not, okay, so for that what we have to do is we have the command peer lifecycle chain code query committed. Okay, in the query committed, I will pass the channel ID and the chain code name. So I will get, okay, on this particular channel these many chain codes has been installed. Okay, so let's run this. So you can see here committed chain code definition for chain code fabcar on channel my channel, and version is 1, sequence is 1, endorsement plugins ESCC. So here you can check it out here. ESCC is a system chain code, if you remember. Validation plugin VSCC, that is also system chain code. Okay, then approval. So from how many organizations you got the approval? So you got approval from org1 also and org2 also, right? Yeah. After that, the same thing if you want to try it out from first organization also. So this is the way you can do it. Just set the environment variable and run the same command. So we'll get the same output like this. Okay, so this is the complete process of chain code life cycle. Okay, and also the chain code also, like if you want to understand the complete thing, like complete procedure of deployment of the chain code, this is the complete procedure. Now we have the shortcut also, right? While using the deploy cc function, which is written inside the network.sh. Okay, so which generally we run, like in shortcut also. This all 18 steps can be done by a single script also. Okay, so in the single script, that script is written in here in the network.sh. In the network.sh, if you search for deploy cc, this function, call the script to deploy a chain code to the channel. Okay, so if you run this, all 18 steps will run automatically. Okay, you don't have to do anything. Only for learning purpose, we have like segregated, or we have just cut those complete thing in the smaller steps. Okay, to understand better. Clear? Now, next thing is, let's say if you want to upgrade the chain code, then what will happen?
Upgrade means if we change any custom logic.
Yes.
Instant. Okay.
Yeah. So let's say some. So today you have installed one version, and after some time there is a business change or business logic change. Okay, and you have updated a business logic in your chain code, right? So then how you will be doing that upgrade? Okay. So there are two ways. One thing is, of course, you can change the chain code name itself. Okay, if you change the chain code name, two chain codes will be running unnecessary. Okay, with different name. But the correct way is just upgrade the chain code. So upgrade the chain code meaning, right now you are running on version number 1. So next version is 2. Okay, so you can run, you can have the second version is version 2. Okay, in that case also, you have to run all these steps. All these steps, only difference would be your version at the sequence number. So instead of 1, you have to put the version number as a 2. And all 18 steps will be repeated. Clear? So take it this as a assignment for you guys. Okay, just try it out with the version 2. Okay. And if you face any issues, then let me know.
Yes.
Yes.
Okay, so now after this, let's try to do some execution on the chain code. Okay, so we have installed the chain code. Now let's do some execution. So this is the link which we are going to follow now. Okay, so in this chain code development and execution, okay, development I will not explain you much. I will explain you when we learn the Go line. That will be very easy. From tomorrow we'll learn the Go line. Okay, so here what I am going to explain you is the logic which is written in the chain code. Okay, the syntax anyway will learn later on, but the logic you have to understand what exactly is written in the chain code. Okay.
Yes.
So with this complete steps, we are going to communicate, or we are going to do some interaction with the chain code. Okay, the chain code which we have installed or we have deployed, will do some interaction with that. Okay, from the command line. Okay, later on we'll learn how we can do from API also. Okay, but right now we'll do from the command line. So the very first thing is, so let's try to okay, we'll do it here and only. So let's clear this out. So the very first thing is, if you are using a new terminal, then you have to export this environment variables. Okay, so let's export the environment variable. I'm just repeating this. If you are running on a same, then it is not needed. Okay, and after that we'll set the connection params to identify the endorsing peers. Again, if you are opening in a new terminal. Okay, then only. So for safer side, I just run this. Okay, now I'm ready to execute any command from org1. Clear?
Yeah.
So what I'm going to do is,
Yeah.
I told you the very first thing which you have to execute, or the very first function which you have to execute, is the init ledger, right?
Mhm.
And this is the command. With this command, we are going to execute the init ledger function, basically a init function. Okay.
Mhm.
So one. Okay. So as I said, like the very first thing is you have to initialize the ledger, okay, or initialize your chain code. Okay. So now try to understand this complete command. What is happening here? So the command is peer chaincode invoke. Okay. If you recall your theory session, I had explained you type of transactions. If you recall, so in the type of transactions, two main transactions will be there: deploy transactions and invoke transactions. Correct?
Yeah.
So deploy transaction we have seen when we were deploying the chain code.
Chain
Okay.
code.
So those things were as a part of deploy transactions. Okay. Now I came to the application logic. Okay. So the logic which we write as a part of our application development. So that logic or those functions will be executed with the help of invoke functions. Okay. Second one is query. So query is when you want to get the data from the ledger, and invoke is when you try to write something to the ledger. Okay. So here, the very first thing, if you see here, peer chain code invoke. Okay. So basically, I'm going to write something to the ledger. Okay.
Mhm.
And here I will give the order information, then core peer TLS enabled, true or false. So for that, CA file is there, order CA, and channel name. So channel name is my channel. Then your fabcar is your chain code. Connection params, just now we have set the connection params from this script. Is in it? Yes. -C for your arguments which you are going to send to the chain code. Okay. So basically with this -C, first we are going to tell the system like which chain code function I want to execute. So the function which I want to execute is init ledger. So let's open the chain code first. So it will be very easy to understand what is happening. So my chain code is fabcar. It is available here, and this is my complete chain code. Okay. So in the chain code, the very first thing is init ledger. This is the function name. Okay. This is a function name which I am going to give here. So basically here I'm telling my system that I'm going to execute this function. So init ledger, and here you can see the function name is create car, right? Here is query all cars. Then here is change car owner, correct? So basically we are just defining here, okay, which function the system needs to execute inside the chain code. And second thing is arguments. If your function is expecting some arguments from you while calling the chain code function, then those arguments you have to provide here. Okay.
Yes.
Here you can see arguments is empty. Okay. It means if you check it out here, this function is not expecting any arguments. You can see here, right? Nothing is there.
So this
The create
PPX
car-
is just a context.
This is just a
Default
context
parameter.
API. I will tell you what exactly it is. But if you see in a create car, it is expecting car number, make, model, color, owner, right? All are in string. But here in the init ledger, it is not expecting any arguments. Okay. So now we are good to go, right? Now
Mhm.
coming to the init ledger, okay, how you write a chain code function. Okay, so in the chain code function, the very first thing in any Go line, okay, the very first thing is you have to import your packages. So it is just like C#. I think in C# you import the packages, right? Or you basically libraries. In
Yeah.
Node.js, you import the modules or packages, right? Similar way here also, the very first thing is whatever modules you are going to use in your chain code, those modules you have to import it. Okay, so here I'm going to use encoding JSON, FMT, and str string conversion, and the last one is contract API. Okay, so contract API is the official library of the Hyperledger Fabric, especially for chain code development. Okay, this library has pre-written functions and the classes which we are going to use to write our chain code. Okay, so if you go on the Hyperledger and you just search for Fabric Contract API Go, you will find the complete documentation also. Okay, so this contract API is available here. Okay, so complete thing is available here. Okay, same thing is available on the Golang also. Golang, the official website of Golang. See here. Sorry. Here. So the complete contract API package, the complete documentation for especially for Golang. So this contract API comes in with Node.js also, I think TypeScript also, and Golang. Okay, so whatever languages which the Fabric supports for the chain code development, all languages will have this contract API package. Okay, so out of this complete functions, okay, we are going to use few functions to write our chain code. Okay, so coming back to our chain code, once we import that, then coming back to here. So basically here this is a function name, okay, and this is a smart contract. Okay, so if you guys remember, I told you there is a minor difference between smart contract and the chain code, right? So chain code is the collection of smart contracts.
Yes.
Right?
Yeah.
In my chain code file where I do the development of my chain code, here I'm going to create this smart contract. I'm not going to use any chain code, right? Chain code is the one which I just combine everything and then create a package file. That is my chain code, right? So here we are going to write this smart contract. So very first thing is you have to define the smart contract. So this is the main function. Here we are just defining a smart contract. Okay, the name of your contract can be anything. This is your contract name. Smart contract is your contract name. It can be anything, whatever name you want to give. Okay, so basically we are just using the contract API and a new chain code function. So if you just search here, new chain code. Okay, so this is the function which we are going to use, and this function will, so new chain code creates a new chain code using contract past. This function parts each of the past function and store details about their markup to be used by the chain code. So basically what it is doing is it is creating a new contract for us. The contract name is whatever name we give it here. Clear? And that contract will be part of our chain code. Okay, now if you have multiple contracts, so you can create multiple contracts like this, and you can combine everything in a single chain code. Clear?
Okay.
Now coming back to here, this is my smart contract. Sorry, this is my contract name. So same contract name I am going to use for in every functions. Okay, so here you can have like multiple contracts, right? So you have to define like this init ledger function is for which contract. Okay, so basically this is a pointer. So I'm just mentioning here, okay, this init function is part of this particular contract. Okay. Now, next thing is CTX. CTX is a part of your contract API. So basically, inside the contract API, every time one function we are going to use, that function name is transaction context interface. This particular function, which is coming from contract API, will help us to do the transactions. Okay, so in every functions which execute a transaction or which help you to get the data, you have to use transaction context interface. This is also available here. This is the one. So defines the interface which transaction context meets. They can take up a function as a contract which has not set a custom transaction context to allow transaction functions to take an interface to simplify unit testing. Okay, so it will help you out to do the unit testing also. Okay, so now after that, simple error. So if any error comes, it will give the error. And here the logic is there. So don't go to the syntax. I will tell you how to write the syntax in Golang. But the logic is we are going to create 10 records when we initialize our chain code. 10 records of cars. Okay, so basically these 10 records will be stored when I execute this function. These 10 records will be created inside my ledger. Clear? Okay.
Yes.
This is what it is doing. It is just a for loop. In the for loop, it is just passing one by one single record. Okay. So now let's execute this. So sorry. So here I am. So let's execute this PR chain code invoke. Okay, so it says chain code invoke successful, result status is 200, right? Now, if you want to check out the logs, so the best way is open your VS Code, go to Docker. In the Docker, you will find the chain codes here, right? So let's check out the logs for our. So here, this is my peer. This is my peer. Okay, so in here you can see committed block 6 with one transaction and hash, right? So the new transaction happened, new block has been created. Okay, so here if you see it is saying finish chain code life cycle, right? After that one transaction happened, that transaction is just now we executed that. Okay,
Yeah.
now so we have executed. Now let's say I just want to get the complete list of the cars which just now we have created. Okay, so for that we have the function query all cars. So query all cars is available here. This one. So basically this function, what it does is it will just return all the cars which it founds in the world state. So remember, it will get the data from world state. Okay, so let's execute, and this is the query function. So when we execute, we'll get the data. The data is coming in the JSON format. Right? The same thing, same data we have inserted also, right? All the 10 records. Now let's say I want to create a new car. Okay. So I have a function here. Function name is create a car. Okay. In this function, my function is expecting I should pass car number, make, model, color, owner. Okay. And then once I pass this, it will come here. It will create a structure here, and then it will store the data inside the ledger. Okay. So here, if you see PR chaincode invoke, channel name, chaincode name, function name is create car, arguments are car 11. So car number, make, model, color, and owner. 5 arguments. My function is also expecting 5 right? So let's execute this. Chaincode invoke successful, result is 200. Now again do the query. You should see a new record, that is car 11. Can you see that? Here. I'm just highlighting. Right?
Yeah.
Okay. So now let's say you want to change the ownership. Okay. So to ownership change, what we need is we just need car number and the new owner name. So car 9 current owner is, where is car 9? 7. This is 8. Okay. And this is 9. Can you see here? I'm just highlighting. So current owner is Shotaro, right? So let's change the ownership of car 9 to Ron. The function name is change car owner. Okay. Now let's try to query. So now you can see here, the owner has been changed. So this is car 9, the owner has been changed. Right? Let's say if you want to do a single query, okay, we want only one record. So for that, you can just pass query car. Query car is the function name. So it will give you the car number 9.
Okay.
We are just giving the indexing, that is car number, and basis of car number, it is giving the output. Fine. So my suggestion would be just try it out this. Okay. Don't worry about the syntax and all. We'll figure out tomorrow. Okay, what exactly we are doing here. Just try to run this commands. Try to run with multiple ways. Okay. If you get any error, that's fine. If you like, the more error you get, the more you will learn. Okay, so that is how it will be.
Yeah.
Right. So try it out, play around it, and then we'll discuss the issues tomorrow.
Yeah, definitely.
Yes.
We'll do that.
Okay, perfect. So that's it for today.
Okay.
Fine.
Yeah. Thanks.
Yep.
Yes.
Thank you.
So tomorrow, basically, we are going to see Golang related stuff.
Yes. So Golang, I will start from the basics and make sure you have installed the Go in your system. So I will explain you the basic concept of Go with the working examples. So it will be easy for you to understand.
Yes. Right.
Okay.
Okay.
Perfect.
Yeah.
Thank you.
Okay. Thanks.
Thank
Thanks,
you.
sir. Thanks.
Bye.
Bye.
Bye.